All right, good morning, everybody. So we're at the last lecture of the year. So for today's lecture, I just want to wrap up the end of the previous lecture. Then I'll hand back your test two, and then I'll talk a little bit about the exam. Is everything up? Oh, we're not. All right. So in the last lecture, we were talking about implementing a queue using an array. Now, just to quickly remind you what's going on, when you're implementing a queue with an array, you want to be a little bit clever about how you keep track of the elements in the array. So we're keeping track of both the front, the location of both the front and the back element of the array. The problem when you do this with the queue is that you have to deal with the fact that your back and front elements can wrap around on the ends of the array. So here we've got an array, it's got one element in it. Sorry, we've got a queue with one element in it. We're going to put a bunch more elements in it. So the front of the queue is here, the back of the queue is here. There's still extra space in the array to hold more elements. So when we can still enqueue 5 more elements. To do that, it's pretty straightforward. You want to start setting the elements at the front of the array now, but you have to wrap the back the back value or the back field to the front of the array again. Right? And so we have to deal with this fact that the both back and front, they're indexes, but they're indexes that can wrap around to the front of the queue. Right? You have to do the same thing with the front. So there's a full queue. Now if you start to dequeue stuff, things come out of the front, so the front marches to the right. Right? When you get to the last element of the array, well, there's still more elements in the queue that are left to be dequeued. So if you dequeue the P, you have to make sure that front goes around, wraps around back to the front of the array. Right? All right, so the way we do that is, just to quickly remind you, right? So when you dequeue, right? To dequeue, all you do is grab the element sitting at the front index of the array. You set that element to null, and then normally you would just add 1 to front. So normally you would just add 1 to front, but to deal with wrapping around back to 0, we're going to take the remainder after dividing by the length of the array, right? Not the size of the queue, right? The length of the array. So if you have an array of size 16, and front is 15, right? Front is the index at the last element of the array. When you add 1 and divide by 16, you get 0. And so front becomes 0. Okay, so to enqueue, it's similar to a stack. So when you push into a full stack, you have to resize the array. So when you enqueue into a full queue, you have to resize the array. The problem is you have to be a little bit careful when you resize the array. Okay, so here we have a full queue. Right, front is the element index 5, back is the element at index 4. Right, so for a stack, we would just make a new array and copy all the elements into the new array. So if you do the same thing for a queue, you end up with a screwed up queue. Right? So there's the original array. Here's my copy that's bigger, it's longer, sorry. Right? All the elements from the original array just get copied in 1 by 1 into the new array. Right? And notice what happens here. The front element is at 5, the back element is at 4, but there's a bunch of empty values in the array here. Right? So when you start to when you start to dequeue, we'll get to the P, and then you're going to keep on dequeuing these elements where there are no existing elements in the array. Right? So you don't want that. So you have to reorder the elements in the queue. In the array. There's many ways to do this. Right? One way to do this is to simply unwind the array, right? So rather than having front start at 5, let's just make front go back to 0, right? We'll have to push the Q, the R, the S, the T, the U, put them on the other end of the array, but that's fine, that's easy to do, right? And so the easiest thing to do when you copy this array into this array is to take the front element and copy it into index 0, take the second element, copy it into index 1, and so on and so on and so forth. Right? So the Q will end up getting copied into here, right? Then the R, then the S, then the T, then the U. Right? So that's probably the simplest way to do things. There are other options as well, right? So you can copy the 5 into the 5, the 6 into the 6, the 0 then goes into the 16, the 1 goes into the 17, and so on and so on and so forth, right? As long as you unwind the elements in the array, everything will be fine. So to NQ, ignore all this, right? If there's space in the array, it's straightforward, right? Add 1 to back, deal with the wraparound, and that becomes your new back index, right? Set the element, store the element in your new back index, increase the size of the queue by 1. If you have to resize, right, you can't use arrays, well, you could use arrays copy here, but you'd have to make a second pass over the array. So instead of using arrays copy, we're going to make our array manually ourselves. Right? So we'll make a new array of object, twice the old length, right? And now copy the elements from the old array into the new array, making sure to unwind the array as you go. So here I'm going to use I as the index into the new array. So I'm going to start counting at 0. I need to copy size elements into the array, so I is less than size. Right? I'm going to increase the index by 1 each time through the loop. Right? So I'm going to assign the elements into temp I. So remember, I is the index into my new array. Right? I need to calculate the index in the old array. Right? So the index in the old array is just this front plus I. Remembering you have to deal with wraparound. So take the remainder after dividing by the length of the old array. Right? Notice this is the length of the old array, not the length of the new array. Right? And so if you write your loop like that, everything's fine. You'll copy the elements into the new array, unwinding as you go. Right? Don't forget to set this ARR to equal your new array. Right? You now have a new front value. Right? So I'm going to put the front value into index 0, so I have to adjust front, and I have to adjust back. Right? So front is 0, and back is just the size minus 1. Right? And then go ahead and add the element once you actually have space in the array to do so. Right? And that completes the implementation of the array-based queue. You could add a bunch of other methods or constructors to this class, right? So toString would be a natural one to add. Equals would be natural. Here's a copy constructor, but it's not like one we've seen before. So you can add a copy constructor to array queue that doesn't copy another array queue. Instead, it can copy any queue, right? So without knowing how other is implemented, I claim you can implement this copy constructor. Right? Similarly, without knowing how other is implemented, I claim you can implement equals and test if any array queue is equal to any other queue. Right? Remember, queue is our interface. All right? It's not an actual class. So you don't know how other is implemented. All that you know is that it has an NQ and a DQ method. So let's go ahead and do the copy constructor. Equals is similar. So there's my copy constructor that copies any queue. Right? Okay, so for an array-based queue, you need to make the array. Right? How big is the other array? Well, it has to be at least the size of O. Right? Now, all queues have a size method, so that step is doable. So this dot ARR, new big object, O dot size. Oh, sorry. Okay, so we now have enough space to store our new, all the elements of the other array, of the other queue. Okay, so now I need to grab the elements from the other queue and put them into this array. Right? When you're doing this, you don't want to permanently modify O. Right? So copy O without permanently modifying. Right? So if someone's giving you a queue to copy, they don't want you to screw around or mess up the ordering of the elements in the original. Right? They want a copy of the original queue, and they don't want you to change the original queue. So here we have to, we're going to copy O without permanently modifying it. So there is a trick here that you can play with queues. Right? And so the trick is, if I take something out of a queue and put it right back in, and if I do that n times, where n is the number of elements in the queue, you end up with the original queue all over again. But you get to look at every element in the queue. So you just write a little loop. I is less than O dot size. Right? So for every element in O is what I want to write. Right? I'm going to dq O. Right? Every time I dq O, that gives me an element. Right? I can put that element into my new queue. So this equals elem. Right? And then I can put the element back into the end of the old queue, of the original queue, sorry. Right? And if you do that O size times, that leaves the original queue unchanged and puts the elements into, puts the references to the elements into this array as well. Right? Don't forget you're keeping track of the size. So this size equals O size. Right? We're keeping track of the front. So this front is equal to 0. Right? And we're keeping track of the back. And so this back is equal to this size minus 1. Or I guess, that's fine, this size minus 1. Right? And so there's how you can implement a copy constructor without ever knowing how that queue is implemented. Equals is similar. So if you want to compare if if an array queue is equals, to some other queue, right? So regular equal stuff goes here. Right, somewhere down here you're going to write Q question mark. Q, yes, Q. There we go. Q question mark. OBJ. Okay. We haven't seen question mark yet. Generics are funny. So normally this would be, in this course, you would cover this in like 4 lectures from now. Obviously, we're not going to get there this year. Generics are funny. So if you want to cast object to a generic type, in Java, you're not allowed to say what type the generic type is. So you have to use the question mark here. Right? Don't worry about it. You're not going to get asked about it on the exam. Right? But once you're here, you want to test if your queue is equal to this other queue, right? And so you're going to play the same trick, right? You don't want to modify the other queue if you're testing for equality, right? So you can play the same trick. You can take an element out of the queue and put it right back in again at the end, as long as you do that for all of the elements, right? And that will leave the other queue unchanged. Right? Now, play the same trick. All right. With the stack, it's similar, except the stack, there's the added complication where if you pop something out of the stack, you can't put it right back in again because it goes back in on the top. So if you want to copy another stack, the trick here is to make a new empty stack, pop all the elements off the original stack into the empty stack, and then pop all the elements off from the temporary stack back onto the original stack. And that leaves the original stack unchanged as well. All right, so that wraps up array-based queues in Java. So normally we would talk about linked node-based queues, and we'd talk about lists. Obviously, we're not going to get there this year, so you won't be asked about them on the exam either. So lecture 28, or lecture deck 28 is the last set of slides that you need to be worried about for the purposes of the exam. All right, I guess I should hand back does anybody have any questions about array-based queues? Okay, so I'll hand back the test 2 by last name. I guess I don't have to record this. Well, it's whatever. All right, so by last name. Anybody with the last name A through F? Anybody A through F? They're sorted alphabetically by last name. G through L. G through L by last name, anybody? Oh, M. M through P. M through P over here. And Q through S. Q through S over here. And I guess I got T through Z over here. Last name? Yeah. Right. X. Renee? Yep. T through Z, anybody else? T through Z?
Michael.
Yep. Okay. Anybody else? T through Z? Yeah.
About the assignment.
Yeah, after.
It's about the 3-day period, because I didn't see that 3-day period on Q.
It's because of, I'm not supposed to make you do work during the exam study session period. Do you need extra time?
Yeah, because I didn't submit it on November 29th. I
Yep.
thought it was a 3-day grace period, so I submitted it yesterday.
Oh,
Would that be fine?
did it accept it?
Yeah,
Don't worry about it, it's fine. Okay. All right, so I don't think there is, okay, so the median on the test was 70. So it was actually done quite well. The problem with things like median and average is that they don't really tell you much. They don't really tell you anything in a course like this. So the grades are all over the place, right? They go all the way from 0 to 100, literally 0 to 100. So things like the median and the average, they don't tell you anything. Distribution looks something like this. So over here's 0 and here's 100. The distribution looks something like that. So it's a big wedge. There's a lot of students who did quite well. Most students, half the students did better than 70, right? There isn't much to say, I think, about the questions themselves. The last question, it was a variation. Everybody got a variation of a similar question. New. So the last question was some sort of transcript of some kind. And you had to keep track of multiple courses and grades, right? So if you need to keep track of multiple stuff, you need some sort of collection, right? So you need an array or a list. The list was by far the easiest way to do this. Right? So you have a list of strings, your courses, right? And now you have the problem of, I need to keep track of courses and grades. So you can either jam everything into one list, which is fine, right? That would be the Python way of doing things, I guess. Well, it'd be the 121 Python way of doing things. It's not the correct Python way of doing things, right? But the easiest way is just to keep a parallel list of grades, right? And now every time you add a course, you add something to courses and you add the corresponding grades to grades, right? To get a grade out of the transcript, you search the list courses, right? By index probably, right? When you find the element that's equal to the course you're looking for, simply return the corresponding element from grades, right? You didn't have to do it this way. You could have mashed everything together, right? So you could do list, string, course, and grade, right? And so now this would be similar to one of your assignments where you had an array that mashed everything together as well, right? So the even indexes would be your courses, your odd indexes would be your grades. You could put all the course, well, no, that'd be awkward. Yeah, that's the easiest way to do, that would be the easiest way to handle that one, right? So even indexes are courses, odd indexes are grades. So you could do it that way as well. Some people try to do it with an array. You can do it with an array if you wanted to, but it's awkward. String, courses. If you had the numeric grade, you would store it in an array of int. The problem with this is you also have to keep track of the number of courses that you have. Right? It's easier to use the list in this case. But all of these would work. Someone managed to do it, I think, with one string, I think. So you could also mash everything into a string, also awkward, right? But it's technically doable. All right, anybody have any specific questions about the test? Okay, so the exam. On OnQ, you've probably seen this already. There's, I think, four either samples or actual old exams. They all have answers to them. So the exams from the previous years, the last question's probably not it's probably not super suitable for this year because we didn't cover as much here as we normally do. So the last question in some of the examples, probably not suitable, right? So let's just take a quick look at what a typical exam looks like. The first question is always some sort of short answer question. The point of this question is it's supposed to be easy for the students to answer, right? So the expectation is that everybody who's been paying attention in the course should get 15 out of 15 in this case. It's not always 15, sometimes it's 10, sometimes it's 12, sometimes it's 20, right? But there's some number of short answer questions. The intent is that they're supposed to be straightforward to answer, so there's no tricks here, right? It's strict recall. They're also easy for me to mark, but that's beside the point, right? So there's some sort of short answer question. I always tell people this, but a lot of students don't listen. Don't answer in full sentences. It wastes too much time on an exam, right? Point form is perfectly fine for a computing science exam. Right? Obviously, English exam, you're going to write in full sentences. Computing science, we don't care, right? Point form is perfectly fine. So these questions span basically 2/3 of the course. So roughly starting from class where we start to talk about classes all the way through to the end, right? So you're not going to see anything about floating point or converting something from Python to Java or something like that, right? Next question here is a little question that asks you to implement a class of some kind. And so this one asks you to implement a ranged value. So a value that's always between some minimum and maximum value. And it asks you to implement comparable, or it asks you about comparable, and it asks you about equals. Right? And so again, basically starting from when we started to talk about classes, these are the questions you should expect to see. This one, so after we started talking about classes, the next thing we talked about was the relationship between classes. So you should expect to see some sort of question that asks you about dependency, association, aggregation, composition. And it's probably going to be the difference between aggregation and composition. Right? And so here, there's this question here. You're given a you're given one of the classes that we studied in the course, right? So this is the list-based stack, right? And it's asking you, is this thing a composition or an aggregation of its elements? That's more or less what the question is asking you, right? You even get a little multiple choice question here. Don't expect to see very many multiple choice questions. I typically don't ask these. Oh, one of the old exams, there's a whole lot of true, false, and multiple choice questions. You're not going to see any of those. They're worth looking at to see what the answers are, but you won't be asked multiple choice or true, false. Okay, so this is basically an aggregation / composition question. Once you've decided it's either an aggregation or a composition, that affects how you implement the rest of the class. So for example, if you're going to have a copy constructor that uses aggregation, the way you implement it is different than if you use composition. So that's what part B is testing here, right? Oh, and that's it for that question, for that particular question. What else did we? Oh, yes. No, I'm not going to tell you. That the whole point of no, the whole point of this course was that you be able to figure out what is the difference between an aggregation and a composition. Right? There's no trick. If the class has some sort of invariant, it's almost certainly a composition. Right? If it has some sort of invariant that involves the fields and the fields are of reference type, it's almost certainly a composition. Right? There's no way that you can ensure the invariants are true if it's not. Right? This is a stack, right? So if this is a properly implemented stack, you shouldn't be able to reach into the middle of the stack and start to change stuff. So this for sure has to be a composition of a list. Right? Whether it's a composition of the elements or not is another story. Okay, and then after we talked about composition, we talked about interfaces and inheritance. So the next question is just a little, in this particular exam, is an inheritance question, right? So you should expect to see some kind of inheritance question. This one uses the counter class, right? And it asks you to implement a counter that you can reset, right? So it behaves the same as a regular counter, except if you can reset it back to 0. And it asks you to keep track of the number of times that it's been reset. Right? So straightforward inheritance question, right? Make sure that you implement, when you implement the constructors, the first line of every constructor is a call to the superclass constructor. And then we had talked about linked data structures, right? Data structures built with a linked sequence of nodes. You should expect to see some question that asks you about a linked sequence of nodes, right? So this one uses the linked stack. Doesn't have to be a linked stack. I could just give you a plain old linked sequence of stuff, right? So I could just give you the node class and ask you some questions about linked nodes. This one asks you to return the bottom element of the stack without changing the stack. Right? So this one's basically asking, can you iterate over a linked sequence of nodes, right? Getting to the last element of the last node in the sequence. And the last question is normally some sort of data structures question. Now, we didn't actually manage to talk about many of them. Any sort of question that you would see here would have to have some extra explanation. This particular question is asking you to implement a small fixed capacity set. That keeps its elements in sorted order. So a set, we didn't talk about the set type in Java. A set is just a sequence, it's a collection of unique elements, right? So no two elements are equal. This one wants you to keep them in sorted order. So you have to remember, how do you sort stuff in Java? Well, there's a comparable interface, right? So you need to use compare to in this when you implement this class. It asks you to implement a set that implements that interface. It tells you use an array of size 8 or something like that. I forget what it says, 8 or 16. It's something like that. It's small, right? So make a fixed size array and create a set using that fixed size array. Right? So it has a size method, so you need to keep track of how many elements are in the set. Right? You know how to do that because we've implemented stack in Q. Right? It's the exact same thing. Return the last element in the set. So this thing's sorted. You have to decide that when you implement this thing, are you going to keep the elements in sorted order or not? You don't have to. And I think the question says don't bother doing it because it's actually hard. It's harder to do it that way. Where is it? Does it tell you not to do that? Oh, it doesn't tell you to do that. Okay, so variations of this question have shown up before. In previous years, I've told students, don't bother sorting the stuff in the array. It's too hard to do, right? If you have a fixed number of elements and you want to get the last element in a sorted sequence, right? Just loop over all the elements, looking for the quote-unquote largest element, right? And return that, right? How do you find the largest element? Well, you're going to use compare to. Right? Contains, you just search the array looking for something equal to obj. Add, it's a set, so you have to check, is there something in the set that's already equal to elem? Right? If there is, you're not going to add the new elements to the set, because sets don't allow duplicate elements. So now you iterate over the elements of the set, checking, or you just call equals would be the easiest way to do this. Right? Is there anything equal to elem? If there is, return false. Right? Otherwise, add the element to the end of your array. And away you go. So there's usually some sort of variation of a data structures question. Whether or not there will be one this year, I'm not sure yet, because we didn't really talk about lists or node-based queues either. If you do see a data structures type question, it will be something you've seen before, or something similar to what you've seen before. Right? I'm not going to throw something brand new at you and ask you to implement it. The exam, I think, does Solus say it's 2 hours in length? Yes? No? Does anybody know? Yes? I think it's supposed to be 2 hours. One of my other courses got switched to 3 for some reason. It's supposed to be a 2-hour exam. And the way that I set the timing for the exam is that if you are confident in your ability, you should be able to finish the exam in half the time. And I can write the exam in about 10 minutes. So that's basically the way I set my exams. So if you find yourself writing like tons and tons and tons of code, something's gone wrong, right? The questions aren't set up to make you write lots and lots and lots of code. Right? It's an exam, right? It doesn't make sense to ask you to write tons and tons and tons of code or tons and tons and tons of text, right? So you want to, if you find yourself writing lots and lots and lots of stuff, stop, right? Reconsider what you're doing and ask yourself, is there perhaps a simpler way to solve this problem? Right? If the answer is no, keep on going. But remember, there probably is an easier way or a shorter way to solve the problem. When you're picking class names and variable names, don't use big names. Right? On the last test, someone had like a class name that had like 8 words in it or something like that. Right? It's just a waste of time on a test or exam. If you're writing professional quality code that lots of people are going to read at some other point in time, yes, pick descriptive names. On the exam, pick shorter names. Don't make them one letter, right? Like I need to be able to understand what it is you're trying to write. But don't pick huge names for your variables and classes. Anything else? So I will put up yet more. I'll put up at least one other old exam, probably the one from last term, the winter term, with solutions for you to look at. Anybody have any questions specifically about the exam? All right. Anybody have any other questions about content in the course? Super. Does anybody have any other questions about anything else? Very good. We're done for the year. So I will look on OnQ for announcements about things like office hours and other miscellaneous course-related stuff. The lectures will be updated later today or tomorrow. So the videos, I mean. If I don't see you during office hours, I will probably see you at the exam.